You want to be able to withdraw $40,000 from your account each year for 15 years after you retire. You expect to retire in 30 years. If your account earns 6% interest, how much will you need to deposit each year until retirement to achieve your retirement goals? So there's two things that are happening here. We have that we want to know the needed deposit each year until retirement to achieve our goal. So that's one part of the problem. And the other part is that we want to be able to withdraw $40,000 from our account each year for 15 years. So that's the other part. What goal do we need to withdraw $40,000 each year? And how much would we need to deposit each year to achieve that goal? So the first thing we're going to do is find that goal that we need using this withdrawal that we want to do each year and the annuity yield formula. Once we know that goal, we can plug it into the needed deposit formula to find then how much we would need to deposit each year in order to achieve that goal. And then our final answer is that needed deposit. So starting with the annuity yield goal formula, where instead of a nest egg, we have our goal, and instead of a monthly yield, we have a yearly yield, since this is a withdrawal each year. That means our in will be 1, since we're withdrawing once each year. R will be our annual percentage rate of 6% divided by 1. So that's 0.06 as a decimal divided by 1, which is 0.06. T equals N times the number of years, 1 times 15, since we are going to withdraw each year for 15 years. So T equals 15. So we'll plug these things into our formula to find our goal. So our yearly yield is going to be 40,000, and we have 1 plus R, which is 1.06, to the T of 15 minus 1 over 0.06 for R times 1 plus R, which is 1.06 to the 15th power. So we'll plug all this in to Desmos to find our goal. So we have a fraction. On the top, we have 40,000 times 1.06 in parentheses, exponent 15, click outside the exponent, minus 1, close parentheses. On the bottom, 0.06 times 1.06 exponent 15. So our goal is 388,489.9595. We'll keep all 4 decimals because we're not done yet. We need to use this number for calculating our needed deposit amount. So we're going to keep all the decimals. We don't want to round until we're all done. This will make our needed deposit answer more accurate. So we found now what would need to be in our retirement account in order to withdraw $40,000 each year for 15 years. That's our goal. Now we'll use that goal to find the needed deposit each year. So again, R is going to be the same because it's the same account, so it's the same APR of 6%, and we are depositing each year, so N is still 1 because it's a deposit each year. So it's 0.06 divided by 1, or 0.06 for R. T this time is different because the years is going to be different. N is still 1, but the years until we expect to retire is actually 30 years. So we're depositing for 30 years. So that's our Y this time. So T is going to be 1 times 30, or 30. So our needed deposit equals the goal that we found, 388,489.95 after the decimal, times R, which is 0.06, over 1.06 as 1 plus R, and 30 for T, minus 1. We can simplify this using Desmos. We have a fraction on the top, a very large number, times 0.06, and on the bottom, 1.06 exponent 30, click outside the exponent, minus 1. So we get $4,913 and about 98 cents if we round it to the nearest cent. So this is how much we would have to deposit each year for 30 years in order to be able to withdraw $40,000 each year 15 years after we retire.